Hi, today we're going to continue with SBAC review day 3, and we're going to be taking a look at the number and quantity examples in this unit to help you review for the SBAC test that is coming up. Question 1 is dealing with selecting the expression that is equivalent to the 18th root of 4.5 to the 6th power. So this problem is asking you to see if you know how to express a radical form, which is the current form, turn it into a rational form. Rational, by the name of it, means fraction. So we're going to need to rewrite the problem with the base of 4.5 with a fraction power. So I tell my students what's on top stays on top. So the 6 is on top right here. It's going to stay on top, and it's going to be over 18 root. And reducing the fraction 6 over 18, we will have 1/3. So the answer is most close to answer choice C. So that is the rational way of expressing the original radical form. And for the next problem, before we answer question 2, let's go over and review what rational numbers and irrational numbers are. So the definition of rational number is anything that can be made by dividing two integers. So any fraction basically is going to be a rational number. So here is an example. 1.5 is a rational number because 1.5 can be expressed as 3 over 2, which means it can be written as a ratio. So therefore, this is a rational number. Here is another definition. A rational number, again, can be written in any form of P over Q form, which means it's a fraction. And the only restriction is that Q cannot equal to 0 because you cannot divide it by 0 in a fraction. Otherwise, you would have an undefined problem. And here are some more examples of rational numbers. The number 5 can be written as 5 over 1. 1.75 can be written as 7/4. And anything basically that can be written as fractions is considered a rational number. So therefore, those are all examples of rational numbers. But if you take a look at the last question here, radical 2, if you take the square root of 2, it is an never-ending decimal of 1.4142, so on and so forth. It is never ending, so therefore we cannot express that into a fraction. So therefore this is not a rational number, and in fact any radical is considered an irrational number. So here's a definition of irrational number, is that the numbers that cannot be expressed as the ratio of two numbers, that is considered an irrational number. For example, pi is a number that is never ending, and therefore we cannot consider that rational, so it is irrational. Another one would be the number e. E is probably approximately the 2.71828, and it continues. It's never ending, so it is also considered an irrational number. And so is radical 2, radical 5, radical 7, so on and so forth. There's many numbers that are irrational because they are in radical form. And so here's more explanation that if you can express something that is not in, if you cannot express it as a fraction, it is irrational. Okay, so let's go ahead and answer question 2. Select the appropriate box to identify each expression as having either a rational or irrational sum. So some of the rationals we can simplify and turn it into rational. Let's take a look at the first one. Radical 25 is actually equal to 5. And radical 16 is actually 4. So if you add it up, you will have 9. And that is clearly a rational answer. So therefore, that is rational. Next one, we have 4 minus radical 25 is 5. That will give us answer of -1. And again, that would be rational. But if you take a look at the next one, radical 12 is actually 4 radical 3. Actually, it should be 4 times 3. And then radical 36 is 6. We know that radical 4 is 2, so 2 radical 3 plus 6. Because of that radical 3, this answer is going to be irrational. And the last one, radical 5 and radical 7 are both irrational numbers, so when you add them up, you will also have an irrational number. And that is the end of question 2. Number 3, select an expression that is equivalent to 7 to the 2/5. This problem is currently written in the rational form, but they want you to, looking at the answer choices, express this in a radical form, which means in root form. So this will be the 5th root based on the number on the bottom. And so to rewrite this with a base of 7, and what's on top stays on top, so the 7 squared, 2 is going to stay on top, and this becomes the 5th root of 7 squared, and that is answer choice A. And that's the end of the problem. Number 4, select an expression that is equivalent to 5th root of 6 cubed times 5th root of 6 to the 4th. And again, these are in radical form, so we're going to rewrite it as rational form. So that will be 6 to the, what's on top stays on top, 3 over 5 times 6 to the 4 over 5. And based on the product power form, we are going to combine by adding the powers. So 3/5 plus 4/5, which gives us 6 to the 7/5. And that looks like answer choice B. Number 5, and it looks like I've already worked out the problem, so let's go over them. So select all numbers that will produce a rational number when multiplied by radical 7. So I've already gone ahead and multiplied each number by a radical 7 in each problem. So let's take a look at the answers. Radical 7, the first one is going to have 7 radical 7, and because of that radical 7, the answer is going to be irrational. 50 times radical 7, and because we are going to have actually 50 radical 7, the answer is also irrational. We can rewrite the 28 as 4 times 7. Radical 4 is 2. 2 times radical 7, and then times the radical 7. So this is equivalent to radical 28 right here. And then times radical 7. 2 radical 7s make a 7, so we have 2 times 7, which gives us 14, and that will be a rational number. So we're going to check off the box here because 14 is actually a rational number. And next one is radical 1 is actually equal to 1. 1 times radical 7 gives us a radical 7. That will be irrational. So we're not going to check off the box. Next one, radical 7 times radical 7 will give us 7. That will be a rational number, so we're going to check off the box. And the next one is radical 14, which can be rewritten as 2 times 7. And then radical 7, but 2 radical 7s will make a 7. So we have 7 radical 2. And because of the radical 2, this is an irrational number, so we're not going to check off the box. So the only 2 that will produce a rational answer when you multiply by radical 7 is the 3rd box and the 5th box. And that is the end of the problem. Next one, number 6, we are selecting an expression that is equivalent to 7 to the 3 over 7. Again, the problem is written in rational form, and we're going to rewrite it in radical form. So that will be the 7th root of 7 cubed, and that is answer choice C. Number 7, let both x and y represent rational numbers. Decide whether each expression is sometimes, always, or never a rational number. So if we multiply, add, subtract, or divide any of the rational numbers, we should be able to get a rational answer back. So all of these are rational numbers. An example of a non-rational would be if you already have a irrational number on top, like such as rational 5 divided by 2, you're going to have an irrational answer because of the radical 5 on top. So otherwise, you should have all rational numbers. Number 8, given the formula dr equals the distance over time, you are asked to find the unit of measurement for the rate, which is given by distance divided by time. So if you look at the distance divided by time, the distance is given by feet, and then the time is in seconds. So the unit of measurement should be feet over second, and so the answer is B. Number 9, a 90-foot rope starts uncoiling. It is then coiled up at the rate of 15 feet per minute. Let Y represent the length of uncoiled rope after X minutes. So it is being coiled up at a rate of 15. So we can represent using these two equations, y equals 15 times x, that's the rate that is being coiled up. And then we have the fullest, the longest that it can reach is 90 feet. So if you solve the equation, 15x needs to be less than or equal to 90, we will have x is less than or equal to 6. So if you were to graph this on a graphing calculator, the window, x-axis would represent the time, which is in minutes. So that's between 0 and 6 minutes that it will be fully coiled. And then the y-axis will represent the length, right here, length of the rope. So it will be maximum 90. So the most appropriate window is the second one, 0 to 6, and then the y-axis between 0 and 100 to 100, which includes the 90. So it's big enough to cover. So I would choose either first one or second one, but most appropriate, I would choose second one. Number 10, given the formula, volume equals 4/3 pi r cubed, and it's asking for the unit of measurement for the volume. So since we know the volume is 4/3 pi r cubed, the only variable is r in this case, and is represented by inches. So therefore, unit of measurement will be inches cubed, which is answer choice B. Number 11, Melissa borrows $200. She earns $250 a day. Let Y represents the number of dollars she has in X days. So if we including the amount of money that Melissa borrows, then the amount of money she has in X days will be 250 times X plus the 200. Without it, it's only going to be Y equals 250X. So if we just only count how much money she makes, then that will be 250 times X. And if we were to count how much she would make in 10 days, that will be 250 times 10, which is $2,500 that she will have. So if we were to graph this on a graphing calculator, we would have to set the window. So x-axis will represent the number of days, which goes from 0 to 10. And then the y-axis is the amount of money she will have, which is, in this case, the maximum is $2,500. So she will have what would be an appropriate window. So for the x-axis, it should go from 0 to 10. In this case, the first choice is not a good choice, so we're going to select no. Second choice, go between -1 to 14. That would be a good window. And then if we look at the y, though, it only goes up to 250, so this would also not be a good window to choose because of the y. The next choice is for x is between -1 and 14. That is a good window. And the y goes up to 2,500. So that's also a good window. So this is a yes. And the last one is it does not need to be 240. And then 13 is not enough to cover the dollar amount. So that's not a good window. So those would be the answers. Number 12 is asking again for the unit of measurement for the area of the circle. And because we know that area is pi r squared, the radius is the only variable here. So radius is given in feet. So that will be feet squared. And so the answer is A. Number 13, Lynette, at breakfast, Lynette is drinking her juice out of an aluminum can. She claims that if the radius of the can is tripled, the volume of the can will be greater if the height is tripled. So she is claiming that if the radius is tripled, then the volume will be greater than if the height is tripled. So we're going to actually work out both scenarios. If we triple the radius, So a volume formula for the aluminum can. Notice the aluminum can is in the shape of a cylinder. So the volume is given by pi r squared h. And if we actually triple the radius, then it will be pi times 3r squared h, which gives us 3 squared, which is 9, and then pi radius squared h. And then if we take a look at the second scenario, the volume when the height is tripled, and see what would happen. We will have pi radius squared. H is now going to be 3h. And so notice that square does not apply to that. So we're going to have 3 pi r squared h. So if you look at the answer choices, choice A, Lynette, is correct. Tripling the radius makes the volume 9 times as great, and tripling the height makes the volume 3 times. So you notice that the first case, when we triple the radius, is 9 times as much, and then the second one is only 3 times. So looks like answer choice A is the correct answer. And if we just go through the next choices, Lynette is correct. Tripling the radius makes the volume same. That would not be true. Is not correct, and that would not be true. So she would only, the only answer that makes sense is answer choice A. Number 14, the inequality x to the 3 over 2 is greater than 1 is true for some values of x. Which description of the interval of x makes the inequality true? So if we actually start with this expression and try to solve for x, we will have, first thing we should do is raise it to the reciprocal, which is 2 over 3, and that will cause the fraction to cancel out. And we do the same thing on the other side, 2 over 3. We have x is greater than 1 to the any power is 1. So we will have the answer, all of them have absolute value, so we just need to look at the end answers. The x is greater than 0, that is not the answer. X is greater than 1 is what we're looking for because that is what we have. Less than 0 again is not answer, and less than 1, that's not the answer. So the only answer that makes sense is answer choice B. And that is the end of day 3. And go ahead and work on your worksheet 3.